In this video, let us continue to solve problems based on applications of sine rule in heights and distances. And so here we've got a problem based on the same. So the problem reads like this. It says a person standing on the bank of a river observes that the angle subtended by a tree on the opposite bank is 60 degrees. When he retreats 20 meters from the bank, he finds the angle to be 30 degrees. Find the height of the tree and the breadth of the river. All right, so this is the question, a pretty straightforward one, I'd say. The first thing that we have to do is let's get a diagram to represent the whole problem. Let's look at the problem diagrammatically. So here it is. All right, here we are with the diagram. You can see that AB is the tree that we're talking about here. It says a person standing on the bank of a river. Okay, first let's talk about this person who's standing on the bank of a river. Let's say P is the person who's standing right here. This is the bank of the river. All right. And now that he observes that the angle is subtended by a tree on the opposite bank. So he sees a tree on the opposite bank. So the tree is here, AB. So let's say the point A is the opposite bank, or point A is one bank and point B is another bank. And in between A and P is a river that is flowing. So he notices a tree, or he observes a tree that is on the other side of the bank, which subtends an angle of 60 degrees on the opposite side of the bank. All right, that is 60 degrees right here. So now what he does is, he retreats 20 meters from the bank. So right now he's here at P. He retreats, or he goes back 20 meters from P to Q. So he comes here 20 meters. Now he observes that. Now he finds the angle to be 30 degrees. When he stands here, the angle that is subtended by the tree is 60 degrees. When he stands at this point, it is 30 degrees. All right. So now this is the data that is given. So using these data, we have to find the height of the tree, that is the length of AB, and also the breadth of the river. The breadth of the river is AP, so we have to also find the length of AP. So these are the two things that we have to find, and we're going to be mostly using the sine rule to solve this problem. All right. So here we are. Let's start off this problem now. So we have now angle ABQ equal to 60 degrees. Here it is, angle ABQ, which is equal to 60 degrees. That is, this entire thing equals 60 degrees. Why? Because we know that the tree is at right angle to the bank. All right. And here we've got a 30 degree. Let's consider the bigger triangle. Let's leave the smaller triangle here. Let's consider the bigger triangle. We've got a 90, we've got a 30. So add up the angles and subtract it from 180 degrees, and then you get a 60 for this. So angle ABQ equals 60 degrees. Now the reason we are finding all these things is to use the sine rule, we need as many angles as possible and as many lengths as possible, because it is mainly the sine of the angle in question and the side that is opposite to it, right? So here we've got angle ABP, which is equal to 60 degrees, and angle BPQ. Angle BPQ equal to 120 degrees. The reason being, angles on a straight line equals 180 degrees. So 60 plus what equals 180 degrees? It is 120 degrees. So angle BPQ equals 120 degrees. And angle PBA, that is angle PBA, this particular angle, let me point it out to you, the one in the pink, this angle equals what? 60 plus 90 subtracted from 180 degrees, you get 30 degrees. This entire thing here, that is 60 degrees, right? So this is 30 degrees. So angle PBA equals 30 degrees, right? Now let's go to the triangle BPQ. Let's go to this triangle here, B, P, and Q, all right? So going to the triangle BPQ, we have angle PQB equal to 30 degrees. It's already given. It is right here, 30 degrees. It is given already. And then we have angle BPQ. Angle BPQ, 120 degrees. We already discussed about it. But then, when we're talking about this triangle, we need to talk about the angles in it. So that's why the repetition. And then we've got the angle PBQ. So here we've got PBQ. So we're just considering only this triangle now. So we've got 120, we've got a 30. 120 and a 30 makes 150 degrees. Subtracting 150 degrees from 180 degrees gives you 30 degrees. So this particular angle, this is again a 30 degrees, right? So now we have angle PBQ equal to 30 degrees. So we've got as much data as we need to solve this problem. So all that we had to know to get all these values were basic geometry, basic triangle concepts. That's all. You just have to know that the sum of the angles of a triangle equals 180 degrees. Nothing more, nothing less. So now, going further, the next step that we have to do is we need to apply or use the sine rule in both the triangles. That is, in the triangles BPQ and then in the triangles PAB. You'll know why. So now, applying the sine rule in the triangle BPQ, we have, because we need to find AP and AB, that's all, right? So we need to try and involve these as much as we can, right? Now to get AB and AP, we also need this side PB, which is part of this triangle also. So that's why we are also considering this triangle. So now, considering the triangle BPQ and applying the sine rule, we have so here we have it. We have BP. We definitely need BP, right? So BP divided by the sine of the angle opposite to it, which is PQB. So that's exactly what it is. And PQ. PQ divided by the sine of the angle opposite to that, which is QBP or PBQ. Here we have. All right, now. And let us now apply the sine rule to the triangle PAB. What we have is alright, here we have, after applying the sine rule to this triangle PAB, we have BP divided by, now we are using all the sides divided by their respective opposite angles, the sine of the respective opposite angles. So we have BP divided by the sine of the angle opposite to it, which is PAB, and then we have AP divided by the sine of the angle opposite to it, which is ABP, and then we have AB divided by the sine of the angle opposite to AB, which is sine of APB. All right, now let's just substitute. Let's first use this. We know that PQ is 20, right? The value of PQ is 20. So we need to find BP. So BP will be equal to PQ is 20 times sine of angle PQB will go to the right hand side top. So angle PQB is what? PQB is 30 degrees. So sine of 30 degrees is a half. So 20 times half divided by sine of PBQ. Sine of PBQ, which is equal to 30 degrees again. So we have another half divided by another half. Sine of 30 degrees is half. So half and half gets cancelled. And then we have BP equals 20 meters. So we've got BP to be equal to 20 meters. So now what we can do is we can use the value of BP and substitute in these two things to find the value of AP, which is going to give us the breadth of the river, right? So now we have, let's substitute BP here. We have 20 divided by sine of angle PAB. Sine of angle PAB is 90 degrees. Sine of 90 degrees is 1. So equals AP is what we have to find. So AP divided by sine of ABP. ABP is 30 degrees. Sine of 30 degrees is a half. So AP divided by half. So we have AP equal to 20 times half, which is equal to 10 meters. So we found AP to be equal to 10 meters. So the breadth of the river is 10 meters. So we found one now. All we have to do is find the height of the tree, which is AB. So now that we know the value of AP, which is 10, we can use these two and find the value of AB. So substituting the value of AP here is 10 divided by sine of ABP. ABP is 30 degrees, so sine of 30 degrees is half. ABP is 30 degrees, so it's half. And AB is in question now. And sine of APB is 60 degrees. Sine 60 degrees is root 3 by 2. So root 3 by 2. So we have AB equal to 10 times root 3 by 2 divided by half, which is nothing but 10 times root 3 by 2 times 2 by 1. The reciprocal of this comes on the numerator. The 2 and 2 gets cancelled, and we have 10 times root 3 meters as the value of AB. So therefore, let me write it here. Therefore, AB equal to, or the height of the tree equals 10 times square root of 3 meters. So we found the height of the tree as well, which is equal to 10 times square root of 3. All right. So those are the two things that we had to find, and we found exactly that. So that's how we apply sine rule in problems related to heights and distances. All right. So that ends this problem as well as this video. I'll see you in the forthcoming videos with more problems based on the application of sine rule in heights and distances.